Welcome to Mathenatic. We are busy with June 2024, paper 1, and we are starting with question 1. Question 1.1.1. Here we have 3x squared plus 5x equal to 0, and we want to solve for x. So what I realize is that in these two terms, I have a common factor of x. So I'll factorize out the x, and that means in the first term I'm left with 3x, and in the second term simply 5, and that is equal to 0. Now I use the zero factor rule where I set every factor equal to 0. So my solutions for x are x is equal to 0, or 3x plus 5 is equal to 0. And when I solve for x now, I have x is equals to negative 5 over 3. Because I take the 5 to the right hand side and then I divide by 3. Question 1.1.2. Here we have 4x squared plus 3x minus 5 equal to 0. And it says answers correct to 2 decimal places. So we want to solve x correct to 2 decimal places. Now that's an indication that you would need to use the quadratic formula, which you can find on your formula sheet. So the a value from our quadratic formula is the coefficient of x squared. The b value would be the coefficient of x. And the c value would be negative 5, the constant value. So when I substitute, I have negative plus 3 plus minus b squared, which is plus 3 squared, minus 4 times a, which is also 4, and c, which is negative 5, and that's underneath the square root, over 2 times 4, which is the a value. And when I simplify by using my calculator, I have x is equals to 0.8, or x is equal to negative 1.55. Question 1.1.3. Here we have x minus 1 squared minus 9 bigger or equal to 0. Now there are two ways to solve this. The shorter way would be to identify that this first bracket is a square and that 9 is a square number as well. So I can say x minus 1 minus 3 times x minus 1 plus 3. So I identify the difference of two squares. But that is a little bit complicated for most students. So let us take a little bit more of a natural approach. So naturally, we want to multiply out those brackets. So when I expand, I have x squared minus 2x plus 1 minus 9 is bigger or equal to 0. Then I add my like terms together, and that is x squared minus 2x minus 8. Now what I can do is I can factorize this trinomial, and I hope you have practiced your factorization. So I'll have x and 4 and x and 2. This will create the 8. So 4 times 2 would be the 8. But I need a negative 2x in the middle. So I'll have x minus 4 and x plus 2. So look, when I factorize, it's minus 4 times plus 2 will give me minus 8. But minus 4x plus 2x will give me negative 2x. That leads me to two critical values of x is equal to 4 and x is equal to negative 2. Now what I prefer to do is use a number line, and I draw a quick parabola on the number line because this is a parabola. And the x-intercept of that parabola is negative 2 and plus 4. And I'm looking on the parabola where the parabola would be bigger or equal to 0. So can you see to the right side of plus 4, the parabola is above the x-axis, so it's bigger or equal to 0. And to the left of negative 2, it is also above the x-axis, where it will be positive. So therefore, we can say x is smaller or equal to negative 2. So I'm moving towards the left of negative 2. And x is bigger or equal to 4. So I move towards the right of 4, because that is where the parabola is above 0. Question 1.1.4. Here we have 5 to the power of 2x minus 5x is equal to 0, and we want to solve for x. What I recommend you do is replace 5 to the power of x with k. So we can say let k be equals to 5 to the power of x. And then we can rewrite the equation as k squared minus k is equal to 0. Now I can see there's a common factor of k. So I factorize out the k, and I have k minus 1 in brackets. And then I solve the equation in terms of k. So I set k equal to 0 and k minus 1 equal to 0. So I have k equals to 0 or k minus 1 equal to 0. So therefore k can be 0 or 1, but this does not solve for x. So what I need to do is I replace k with 5 to the power of x. So I have 5 to the power of x is equals to 0, or 5 to the power of x is equal to 1. Now, there's no way of writing 0 as 5 to the power of something. So there is no solution on the left-hand side. But on the right-hand side, I can rewrite 1 as 5 to the power of 0. So I'm writing 1 as 5 to the power of 0, and I can see that x is equal to 0. So therefore, x is equal to 0. Question 1.1.5. Here we have x divided by the root of 20 minus x is equal to 1. So what I'll do first is I'll cross multiply to have x equals to 20 minus x. So what I'm doing is I'm taking the denominator and I'm multiplying that with 1, and that leads me to x equals to 1 times the root of 20 minus x. Next, I'll take the square on both sides to get rid of the square root. So that leads me to x squared on the left is equal to 20 minus x. Because when you square a square root, you're left with the contents of that square root. Now I'll write the equation in standard form. So I'll have x squared plus x minus 20 is equal to 0. And this is an easy trinomial that I can factorize. So I'll have the factors of x, which is x times x, and the factors of 20, which is 4 and 5, which will lead me to a coefficient of 1 in the middle. So therefore it will be plus 5 and minus 4. So I can have two possible values for x. X would be equal to 4, or x is equal to negative 5. Now it's important with square root questions to always check your answer. So what I mean by that is you take 4 and you substitute it into the original equation to see if it will be equal to 1. So we'll have 4 divided by 20 minus 4, which is the root of 16. And that is 4 over root of 16, which leads me to 1. So the left-hand side is equal to the right-hand side. Therefore, x can be equal to 4. Now let us test negative 5. So if I put in negative 5 in the place of x, it will lead me to negative 5 over the root of 25, which leads to negative 1. But negative 1 is not equal to positive 1. So therefore, x cannot be equal to negative 5. So remember to check your values in the original equation. You can also use your calculator to do this. Question 1.2. Here we want to solve x and y simultaneously. We are given two equations. In the first, we have x plus y equal to 9. And in the second, 2x squared minus y squared is equal to 7. So what I would like to do is I'm going to rewrite the first equation, and I'll have x as 9 minus y. So I'm solving the equation in terms of x by moving the y to the right-hand side. Now I'll take this x and 9 minus y, and I substitute it into my second equation. So I'll have 2 times x, which is 9 minus y squared is equal to 7. Notice that I'm using brackets to show the substitution, and I'm squaring the full bracket. So now I need to do a little bit of algebra. Let's expand the brackets. So I'll have 2 times 81 minus 18y plus y squared minus y squared is equal to 7. So remember, 9 minus y squared expands to 9 minus y times 9 minus y, and then you need to FOIL properly. Now let me multiply the 2 in. So I'll have 162 minus 36y plus 2y squared minus y squared is equal to 7. And if I rewrite the equation in standard form, I see that I have 2y squared minus y squared, which simplifies to y squared. Next, we have negative 36y, and there are no other like terms. And then I'll have 162 minus 7. So I'll bring the 7 to the left-hand side. And that becomes plus 155 is equal to 0. Now, normally here, people would use the quadratic equation to solve y. But if you're comfortable, you can always try to factorize this as well. So the factors of y would be y times y, and the factors of 155, that gives me 36, would be 31 times 5. That gives me 155, and I need to have minus 36 in the middle, so it's minus 31 minus 5. Therefore, y would be equal to 31, or y would be equal to 5. And now I have my equation for x, which is 9 minus y. So we'll have 9 minus 31, or x is equals to 9 minus 5. So that leads me to an x value of negative 22, or an x value of plus 4. Question 1.3. Now this is our problem solving question in question 1 of paper 1. What I recommend is, if you are intimidated by this question, that you rather leave some space open on your question paper and move on to the questions that are a little bit more familiar to you. You can always come back and try and answer this question. So here we are given that P is equals to 1 minus A, and T is 1 plus A times 1 plus A squared plus 1 plus A to the power 4, all the way to 1 plus A to the power of 512. These ellipses mean that this pattern continues all the way up until this last bracket. And it says determine the value of P times T in terms of A. So let us start with that. We'll have P times T, and that is equals to 1 minus A times 1 plus A, 1 plus A squared, and that continues all the way to 1 plus A to the power of 512. And if I focus on the first two brackets, I notice that that creates a difference of 2 squares. So that will become 1 minus A squared times 1 plus a squared times 1 plus a to the power of 4, all the way to 1 plus a to the power of 512. And can you see that from our first result, we'll also create another difference of two squares. So let's do that quickly. We'll have 1 minus a to the power of 4 as the result of the first two brackets times 1 plus a to the power of 4, and that continues all the way to the last bracket. So what I'm noticing is if I multiply p with t, the first two brackets create a difference of two squares. Then if I take that result and I multiply it with the next bracket, which is 1 plus a squared, I also have a difference of two squares. And that will continue all the way up until the last bracket. So I'm spotting a little pattern here. That means my last set of brackets would be 1 minus a to the power of 512 times 1 plus a to the power of 512. And if I expand this difference of two squares, I have 1 minus a to the power of 1024. And now I have simplified p times t in terms of a to two terms. So in terms of the mathematics, it's not too difficult. It's all about seeing the pattern and then following that pattern through and making a proper conclusion. But like I said, if you are struggling with these types of questions, rather leave them out and move on. You can always come back at the end of your exam. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.